It turns out no amount of tweaking your CLAUDE.md will stop the slop getting into your codebase. Things slip through and sometimes agents just completely ignore the rules. But luckily, the humble Linter is here to save us. Anti-slop are rules for Oxlint that reject low evidence and low signal TypeScript and JavaScript patterns. So in this video, we'll go over how to use these in your project and how they can help your agents produce better quality code. So anti-slop are just lint rules that can catch low quality code at its source. The repo comes with a long list of different rules to catch things like chain type assertions, unknown parameters, and unknown returns. Now, you may not agree with all of these rules, but the point is not to use them all. It's to handpick the ones that match your team's standards. And linting is a great way to do this because it's a hard fail on things you want to keep out. This can save you tokens and deterministically block the slop. Adding rules to CLAUDE.md, on the other hand, can work, but it's easy to circumvent, and sometimes the agents just don't follow the rules anyway. However, linting, by contrast, is faster and cheaper and more effective at detecting obvious patterns. But you're probably thinking, so what? We've had linters for ages, so who cares? Well, not only do these show the errors, but they also do a great job of explaining why the error occurred and how to fix it. And that is pretty juicy data for your agents to use, which is so much better than the typical almost unreadable junk that you get from standard TypeScript errors. So let's jump into a demo to see how all of it works. And if you want to stay up to date with open source tools, then do me a huge favor and subscribe to BetterStack. So here I've got a file which purposely includes a bunch of errors coming from the lint rules in the anti-slop package. Here at the top, you can see that I've typecast twice, first to unknown and then second to user. Typically, you might do this when you're getting a response from a JSON API, but then we can see that we have very descriptive errors on both what the issue is and then how to fix it. So for this particular error, it says that this assertion chain discards a type evidence, which is true. And the solution would be to keep the original precise type or pass untrusted input at its boundary before narrowing it. So this would be using something like Zod to first guarantee the type safety before moving on. You can see another similar example of this as well. So here we're returning data from a JSON API and then we're just returning it. But JSON actually does return in any type. So here at the function, we're returning unknown. But this again is a bit of a code smell. So it says this function exposes unknown to its caller, pass the value at its boundary and return a named domain type. So let's run Claude and see how it handles all of this. So let's just say fix all issues in API client. So you can see after running for a few minutes, all of the issues have been fixed. And the loop here would be that inside package JSON, we call lint, calling Oxlint source. And then we got our lint config itself, including almost all of the rules in this case. So the agent would produce the code, potentially make the mistakes, run lint, notice the errors and then repair them. And that way you get much better quality code going to production. None of the errors we catch with these lint rules are bugs. The code could still compile, but it's about catching low evidence, low quality code early before real bugs are introduced. Chain casting is a good example. Say I'm pulling an account back from an API, I can cast the response into the shape I'm expecting, and that isn't a bug in itself. It compiles and everything downstream now thinks created at is a date. But of course, JSON doesn't have dates, so what actually comes back is a string. So the first time anything treats that like a date, suddenly we've introduced a bug. And normally TypeScript would have a chance to warn me about this, but it doesn't because I threw away the evidence using the cast. So this package was created just last week, and it runs on the linting package OCX, which, if you're not familiar, is a collection of high-performance JavaScript tools written in Rust. The linter is benchmarked to be 50 to 100 times faster than ESLint, which sounds unbelievable. And I've been using this on all of my projects over the last few months and honestly would highly recommend it. And of course, the reaction online has been super positive, with some users getting slightly more slop errors than they anticipated. So if you want to clean up your code base, you can check out the GitHub link down in the description. Don't forget to subscribe. Thank you for watching. And of course, I'll see you in the next one.